Alright guys, today we're going to take a look at what happens when you combine exponent rules. So in all four of these examples, there's multiple rules. There can be the product rule, the quotient rule, the zero rule, or the negative exponent rule. It just depends on what we see. That will determine what we do. So in example 1, I have 2 to the 4th divided by 2 times 2 squared. So if I look at this, in the bottom, 2 times 2 squared is going to become 2 to the 1 plus 2 power. So I'll have 2 to the 4th over 2 to the 3rd. This is the quotient rule, which says when I divide like bases, I subtract the exponents. So this is going to become 2 to the 1st power, which is equal to 2. In example 2, I have 2 times m to the 4th, 2 times m to the 0 power divided by m to the 3rd. In the numerator, I'm going to go ahead and multiply 2 times 2 is 4. M to the 4th is going to stay. And if you look at m to the 0, you know that's going to be 1, so we really don't need to look at it. In the denominator, I have m to the 3rd. Again, this is going to be the quotient rule, which says when I divide like bases, I subtract exponents. So this is going to equal 4m to the power of 1. In example 3, I've kind of got a lot going on. In the numerator, I'm going to worry about all of this first. Okay, so in the numerator, 3 times 2 is 6. X squared and x to the 4th becomes x to the 2 plus 4 power. And then I have y to the negative 2 and then y to the 1st. I'm going to go ahead and put that together. Negative 2 plus 1. In the denominator, I notice that this has x to the 0, so I know that's going to be a 1, so I'm not going to worry about it. I still have 4 and y to the 3rd. So if I simplify the numerator, I have 6x to the 6th power, y to the negative 1st power. In the denominator, I also have 4 times y to the positive 3rd power. The only thing I need to do is realize that this is negative, and I'm going to bring it down. This becomes 6x to the 6th divided by 4 y to the 3 plus 1 power, because that negative 1 now becomes positive. So I'm left with 6 over 4 is also going to reduce to 3 over 2. X to the 6th, y to the 4th. In the last example, I have 3a to the 3rd, b to the 3rd, over 4a to the negative 2b squared times 2ab to the negative 1 power. If I look at the numerator, I really can't do anything with it, so instead, I'm going to focus on this denominator. 3a to the 3rd, b to the 3rd. Can't really do anything at the moment. In the denominator, 4 times 2 is 8. I have this a to the 2nd, which I know is going to need to be brought up. This b to the negative 1 is also going to need to be brought up. I still have b squared in the denominator, and I have a to the 1st. So in the numerator, I'm going to go ahead and combine everything. 3a to the 3 plus 2 power, b to the 3 plus 1 power, over 8 a b squared. I just put everything in alphabetical order. So I'm going to go ahead and add my exponents. This becomes 3a to the 5th, b to the 4th, over 8a b squared. Now, if I use the quotient rule, This becomes a to the 5 minus 1 power, b to the 4 minus 2 power, which will be 3 over 8 times a to the 4th, b to the 2nd. And that is solving exponential expressions with multiple rules. Have a great day.